So with the help of these wavefronts, we are supposed to analyze the condition. $1.3 meters. So I'll draw the diagram. I'll draw the diagram. Most of you are telling, sir, diagram not clear. Let me draw the diagram. It'll take less time. Circles should be okay. Some rough diagram. Okay, so this is the thing. Now we'll take this reference line. That is a XX dash is telling. So what is this distance? This will be a constant. So how much is telling? 1.3 meter. What about this? This will be 0.9. And there is a source at point A. And there is an observer at point Q. Hope I am explaining everything. What is the content given that one? The sound released at A is heard by the detector at frequency. Okay, we have wavefronts here. So from wavefronts, what do we get? How come? Okay, let's do one thing. What are these wavefronts? Like as the source propagates, what are these circles? These circles are wavefronts. If source is at rest, how the wavefronts will be? I think this is the primary question if which we ask ourselves. I think problem is solved. If source is at rest, this will be the wavefronts. What will be the distance between wavefronts? The distance between wavefronts will be fixed here if source is at rest. Am I right? Okay, fine. So the distance between, if the source is at rest, the distance between wavefronts will be at rest, will be equal. So you call this is x. This idea, for first you have to put it when this is when source is at rest. When source is moving is what we see the wavefronts like this. So definitely the source is rest or in motion in the diagram question given. It is in motion. Okay, now what to do for this? The question is like how to analyze this particular thing. Okay, let's go for the Doppler effect. There are two observers are there. So we'll keep one observer here on the left and other on the right. So let me proceed like this. So this is the source. This observer 2, this observer 1. And let's put that source, let it propagate, and it will generate a frequency, sound signal of frequency f0. That f0 is this one given. What is f0? F0 is Unnecessary has given one more time period. Again, reciprocal of time period should be the frequency only. So you need not to bother that data may not be this is useful. Huh? Both are same. Reciprocal of time period is what? The frequency, no? Now, what will be the apparent frequencies heard by the detector 192? Let's discuss this one. Let me come to the question afterwards. Let's have first a basic idea from here. Okay, what is apparent frequency heard by this person? F1 is equal to F1, the source moving away and the observer is at rest. So where are that observers? As I am going to put that observer over here. I am assuming it. I am assuming it. Okay, what is F1? Doppler effect formula. V F naught by V minus Vs. Can you discuss the wavelength? So here, what is the condition that arises? The wave emitted by this, by the time it arrives here, will become F1. Can you remember? The wave emitted here, by the time it reaches, will become F2. Okay, what is the wavelength? What is the wavelength? Lambda 1 is equal to V relative by F1. What is V relative? Velocity of wave with respect to observer. It is equal to V only. This is the wavelength of waves received by observer 1. Similarly, what is the wavelength of waves received by observer 2? F2 is equal to V F naught by, shall we make it plus? I think it should be positive. Okay, yeah, fine. And the source is approaching observer in the second case. Second case, source is approaching the observer. V relative is what, like, will be V. Okay, I agree this, no problem. Tell me, like, where the wavelength is more. For which observer the wavelength of the waves will be more? For the first observer. For the first observer, what will happen? The wavelength of the waves received by it, what will happen, will be more. For the second observer, the wavelength of waves received by it will be less. If source is at rest, both observers are standing. Then in that case, what happens? Both observers say that we are receiving the waves of same wavelength. Getting the idea, the concept? Just I wanted to test you with the wavefront concept here. Able to understand? This will be okay. No, definitely. Shall we say no? What is the situation now? Something. Do we know wavelength? Yes, the lambda 1 is what? 1.3 meter. Do we know speed of the sound? It is given. Not given. Do we know speed of source? Not there. F naught is given. So what all available? So from this conclusion, what I can write? Lambda 1 is equal to 1.3 meter. Lambda 2 is equal to 0.9 meter. And I know F naught. What are unknown things? V and Vs are unknown. Solving these two equations will get the required answer. I'll let me go for solving. So therefore this will be 1.3 speed of sound. Okay, V plus Vs both are unknown. F naught is how much? F naught is 300. Let me push this to the corner. Then similarly, this will become 300. 13 into 3, 39. 390 equal to V plus Vs. Similarly, looking at this, lambda 2 is 0.9. Solving these two equations will get V and Vs. Okay, after this, he didn't ask these things, no? What he has asked, what is the frequency of the waves received by the observer at Q? There's also one observer is there at Q. At what apparent frequency is going to receive the waves? the waves that are generated by source. So what is the state of source? Source at rest or in motion? It is in motion, no? With this discussion, I'm able to tell it. Okay, let's write the apparent frequency formula. F dash is equal to observer at rest, then F dash should be equal to F into V by V minus Vs cos theta. Theta given 60 degrees. The Vs value is what we are going to get from here. The V value also we are going to get from here. Then we'll get apparent frequency. Okay, are you able to get this? The some very good numerical. Huh? This is something is asking students to imagine the wavefront concept. So your answer then F by 110 is equal to, the answer will be 3. Check later on. I'll go to the next concept. Okay, this idea, okay, fine. The wavelength, what happened? The wavefronts, what happened? The distance between wavefronts is what wavelength, no? I think already we have discussed yesterday's class, so this should be the lambda 1. This should be the lambda 2. Okay, we'll take the next one. I'll read it. I didn't. Oh no. Okay, let me read for you. A source S and a detector O are initially at a distance of x equal to 1 kilometer. Both start moving towards each other with same acceleration, a equal to 10 meter per second square. What is F equal to F naught? I don't know. What is the meaning of this? This is what F naught, ma. The 300 Hz. No, the detector, heard by a detector. Detector what will hear at a frequency. Okay. Symbols, no symbols. I'll change it. F naught. So is that okay now?
Yes, sir.
Then okay. The symbols little bit. F equal to F naught V by V minus Vs cos theta. F by 110 is what is asking. Okay, all the symbols are correct, no? F naught. Yeah, fine. Yeah. Thanks. No. A source S and detector O are initially at a distance of 1 kilometer. Both